Hi and welcome to the Library of Ravens. The Library of Ravens is a simple library management application built with RavenDB, Aspire and Azure Functions. If you want to take a look at it, you can see the source code, you can play with it, get it and run on your own machine, just getting it by going to samples library at RavenDB GitHub organization. There are several features that we'll use heavily in regards to how we'll leverage RavenDB to support the whole application. First, we'll use includes, which is loading related documents. We'll take a look at the document refresh. Also, we'll integrate with Azure Storage Queues. So if you're a cloud person, that might get you interested in this particular sample. Then we'll take a look at the vector search and we'll see how we can play with it. Let's mention a few technologies that we'll use. First and foremost, of course, RavenDB. Then we'll use the most recent .NET 10. Aspire will be used for managing the whole application and helping us in bootstrapping it properly. Azure Functions will be used as the main provider for the API, but also will play a crucial role in regards to the management of the timeouts. Azure Storage Queues will be used to get the sense and get the feeling of integrating with other applications, but also will use them to manage already mentioned timeouts. And the last but not least, the UI will be provided by SvelteKit. I'm not the master of SvelteKit, but I did my best to make it usable. To run this sample locally, you need to perform a few steps like checking out the Git repository, installing prerequisites, meaning .NET 10, Aspire Dev and Node.js. Then you need to grab the dev license, which is available for free from RavenDB site, and then you can get it running. So without further ado, let's dive into how to set it up and how to run it for the first time. So let's get this library started. I assume that you already cloned the repo, installed .NET, Node.js and Aspire. We won't be covering these steps, you can do it on your own. Now let's take a look what the solution consists of. So the thing that is most important one is the Aspire gluing. So this is the core app that will be running, and this is the only app that you will need to run. But Aspire is only the gluing. It's a gluing in the source code. We'll discuss it in a second. As you can see, it consists of a few steps that will combine together themselves and will let your application to be run on your dev machine. The whole application will be hosted as Azure Functions. This is the app library, this is the app project, and it's split into several components that we'll dive into later on. The model is the part that represents your data and things you do with them. So whether it's author, book copy, or the borrowed book, you will find everything in here. But this is not a runnable application. It's just a model project that will be used by the Azure Functions app. The next part related to data is the setup. So it contains migrations that will bring your database up to date. Initially, the database is empty. So we need to put some data in it so you can enjoy the demo of the Library of Ravens. So this is what migrations are for. They move between the versions of the database, populating it with what's needed in there. The last but not least, frontend. This is a really simple front-end done in SvelteKit. You can take a look at it and we'll have it hosted again using the Aspire gluing. So as we mentioned the Aspire gluing so many times already, let's take a look at the app host file that you can find in the app host project. It contains the usual Aspire things, meaning first you create a distributed application, then using the provided builder we register storage components, meaning Azure storage components that locally will be run as an emulator. As I mentioned in the first part, we need to have the Raven license and you need to put it in the Raven license environment variable. The reason for that is that you want to put the license using the fluent syntax with the license. You need to have this license to enable some features in RavenDB. The next step is RavenDB itself. You can use the .@RavenDB on the builder to get the RavenDB properly initialized. Then we'll bump it up to the latest version, we'll get some fancy icon name, and we'll wait for the queues and reference them. The reason why we reference the queues and wait for them is that there is the ETL process that will be used for handling the timeouts. So we need to have the queues that RavenDB will connect to. The next part, related to the command and command key and parameters, is a fancy way of enabling one-click migrations in the Aspire dashboard. To make it happen, we need to add the Azure Functions project, then again we will reference and wait for the queues, we'll provide some connection, we will reference and wait for RavenDB, and then we will add this HTTP command for applying migrations directly through the Aspire dashboard. Again, the last but not least, the frontend. So we use add npm app to get the frontend properly started and to make it visible in our dashboard and then accessible through the provided link. Okay, so we know all the parts that the library of Ravens consists of. We know that the app host is the Aspire gluing component with its distributed application that allows us to just run this single project. So let's get it running. As a person who doesn't live and breathe command line interfaces, I truly like the simplicity of the Aspire. So what we do is that we set the Aspire app host application, the very one that we are looking at for a few minutes now, and we just hit the run button. This is it. What will happen underneath is Aspire will set up everything properly and will show us the Aspire dashboard. As you can see, the Aspire dashboard is ready for our application. Let's take a look what are the pieces, and again they are pretty similar to what we are looking at when we were dissecting the distributed application file. The first and foremost we have RavenDB, and as you can see there is the library which is the database that has been created for us already. As you can see, RavenDB is accessible, so if you want to take a look, you can click on the link and enjoy the RavenDB Studio. Second is the Azure Storage account, which is provided by Azure Storage Simulator. As you can see, we are using only a single component, which is queues. And these queues will be used for the whole cloud-related integration, meaning the timeouts management and all the goodies that we provide and will discuss later on. Then we have the front end, which is this folder kit. There is the command key, so this is a way that we ensure that only the one who owns it, and using the Aspire, we can run a specific migration operation. And then there is the backend, meaning the Azure Functions app, again being run by Aspire and fully integrated with it. If you take a look on the right, you will see this small database button. So this is the actual action that is related to the command key that we just saw above. And if we click it, we will see that there is the migrateDB task being started. This is the task that actually imports all the data that are required for our application to work properly. It also adds a few indices in RavenDB, and then it basically builds up what is needed for us to enjoy the application. As we have the database prepared and we know that thing is set up properly and running because we can take a look at the state here, we can click on the link provided by Aspire again and take a look at the front end. This is the very first time when we are seeing the actual application. There is a small tooltip here, let's close it. And as you can see, it's a very simple app that consists of several views. First, at the top, you can see that there is the search. We'll dive into it in a second. Here are some notifications, so let's just click and see what the notifications are about. We'll discuss them in a second as well. There is the profile that has been automatically created for you. So this is just a random identifier that is assigned to you, and then you can use it in the application as it would be your profile. If we go back to the home page, you will notice that every single page contains two tips. The first is the library tip, which is just a bit about the application to know where we are at and to help us with navigation. And the second is the RavenDB tip that is based and focused on the capabilities that are used on the given page so that you can enjoy it. For example, here you can see that we will integrate Azure Storage Queues. The page heavily leverages the HTTP caching. We'll talk about it in a second. And then it has a nice query capabilities provided by RavenDB. If we scroll down, you can see that there is a lot of books here. If we click on a book, you can see again the same library tip, the same RavenDB tip, some description, and a link to the author. Of course, there is the action of borrowing a book, but we'll discuss it in a second. If we go to the author, again, the library tip, what the page is about, RavenDB tips, what is used on the given page, and then the list of the books written by the given author. As you can see, this is a really simple application that we'll dissect in a second, that allows you to just click through, enjoy the Aspire hosted environment, and see RavenDB in action. So that's the first view. Let's jump into the search now. The library of Ravens tries to do its best to mimic a regular application. So as usual, as you have any kind of a catalog app, you want to search, and the library of Ravens provides you with such a capability. To search, you can click here or use the shortcut, whatever works for you, and then it's similar to any search capability that you see online. Let's start with Harry Potter maybe, and as you can see, it provides you with some results. And of course, this is just the UI, so I won't be focusing on that part. I want you to take a look at different capabilities. So first, right now we are just using a search, a full text search that is provided by RavenDB against the books and the authors as well. So if you want to search for Rowling, you will see that J.K. Rowling can be found in here. Now the question, we have two different kinds of data here, books and authors, and somehow they are indexed in a way that you have one search capability that you can use to search for either the Harry Potter or J.K. Rowling using the very same endpoint. Let's take a look how it is done. To understand how it is done, first we need to take a look at what's the data model that supports the search. The first document type that we can take a look at is the author. As you can see, it's a pretty straightforward and simple document. It has the identifier, first name and the last name. The next one that we were looking at and searching for is a book. A book will have the identifier, the title, and the author ID. In addition, as you notice in the UI, some of the books have a description provided for them. It's worth to mention that the relationships in RavenDB, they are always done by identifier. So here we have a book that was written by a given author, and you won't notice the author entity here, although it can be properly loaded, and we'll see that with include clause. But you can see that this is just the author ID provided as a property. Now let's go one level up and understand how we are capable of searching both books and authors at the same time. To understand how it is done, let's take a look at the global search. As you can see, global search is just a static class, just a wrapper. It provides some result, meaning it provides the identifier of the document that was found and the query. And then there is a definition of the index. In that case, it's called full text indexed, and it will result in results being provided for you. So to make it work, what we do is that we add multiple maps to a simple single index. As you can see, we will map books where the query will be the book title, And we'll add authors so that the query will become the first name and the last name. Then in the index definition, we will ask Laizly to index the query field using the field indexing search. That means the full text search capability. To be able to retrieve results directly from the index, so no additional lookups, just the usage of the index should be sufficient to provide the results in a really fast manner, we will store the query in the index itself. So now when we go back to the UI and we think how it is done, as you can see, for the books, it will be the book title that we will search against, and for the authors, it will be author first name plus last name. Again, we search with the full text search, and the query will be stored in the index itself. Now let's go one level up. To do that, we need to go to the library app because we want to take a look how we actually use the full text index. So to take a look, let's go to the API file and let's take a look how search works. So actually search consists of several parameters. First, the offset, you can provide the offset, then you provide the query, and then we'll see in a second an additional vector search capability that you can use to use the semantic search. If the query is not a vectorized query, meaning the query is not the semantic search, we will use just the full text index as it is right here. So you query the specific index if you want to, and then you obtain the results. To make the query correct, we of course will use the search capability that uses the full text search. And then at the end, we need to transform the results a bit to extract some metadata that later will be useful with HTTP caching. Still, as you can see, the querying of the index and having the capability of including several data sources into a single index is pretty straightforward. Now let's jump back to the main screen of the application or any other screen, and let's use the search once again. As we already saw, there is this small checkbox, use vector search. And the vector search is a very powerful capability. If you don't know what it is, long story short, a vector search allows you to treat the data in a semantic way, meaning that according to the embedding model that it uses, it will try to do its best to find something that is meaningful and similar to the request that we are sending. So let's try the wizard, and we see that we have a few of them. Again, as we are Harry Potter fans, we will click on the Harry Potter and we will enjoy the book that we can borrow. Now you may ask, how hard is it to find the meaning and treat the search in a semantic way? Let's take a look how Raven does it. So let's jump into the API. Again, we'll take a look at the same function. This is the search function that we already covered. And the thing that is changed by applying this small tick in the search box is the vector, and the vector search is enabled now. How is it done? So again, we'll use a query against a specific vector index, and we'll use the vector search with the with field special method that allows you to query the specific field using the vector search algorithm. The last thing that we need to do is that we need to turn the text into the embedding. So we extract the meaning from the query that was put into the search box, and then once the understanding and the meaning is there, we perform a semantic search looking for similar documents. So now let's take a look how the actual index is defined and implemented. As you can see, it's another static index definition. We extended the result, adding one field, and then when mapping things, we create a vector based on either book description, like we did initially with the search, or by creating a vector on top of the first name plus the last name. This is probably will be quite unlikely to produce anything, but I added it just for sake of making it quite similar to the previous full text search that we were using. Again, as you can see, we can use the multi-map, meaning that we can use several sources and add them to the vector search. Then we need to add the vector index because we need to have the vectorized index that will use the underlying algorithm to properly index data according to their meaning. And we need to select the search engine type to Corax. Corax is a custom RavenDB indexing engine that is capable of supporting the semantic search that we need to have here. Let's go back to the search then. As you can see, the usage of the vector search is pretty straightforward. Again, we define a query, again queryable, then we use the vector search, and then we do the get search result. That is our helper method that we already covered. We just gather some stats, we project the result, we skip, take, just basic link related operations. Again, the search itself is really short, and you can see this is just a few lines that allows you to either use the full text search if you want to, or go with the vector search if you want to search for the meaning. Let's go back to the application and summarize it. I think that these capabilities, meaning full text search and the vector search, are really powerful, and you can build a lot with them within just few lines, and of course delegating a lot to the underlying RavenDB. Let's take a look at another aspect that is covered and helped with by RavenDB. Let's take a look at one particular page, which is books details. All of the books that you can see here, you can click and take a look at what the book is about, following its description. You can also see the author, that is also clickable. We can see the availability of a given book and the title, of course. Now you may ask, okay, this is a lot of data. I could say that first, the book itself, that could be one query. Then second, to retrieve the author, we need to add another query. And then to get the availability for the given book, you potentially could issue the third query. Is that the case with RavenDB? So first, just notice how good this page looks like with all the data. And I don't mean that I'm the master of UI experience. What I'm trying to tell is that there is a lot of data in here. So let's dive and take a look how we do this in API and what capabilities of RavenDB and its client library we can leverage to make it fetch the data in just a few requests, if not one. To take a look at it, we'll again visit the Azure Functions app, and we'll take a look at the route that is books/AD. As you can see, it fetches a lot of data and then returns it using the JSON result. Yes, there is one addition that we'll cover later on that leverages HTTP caching, but for now we want to focus on the fetching of the data only. Initially, we can already notice that there is a query. You should be familiar with this pattern already. We are querying some index definition and we want to obtain some results. Of course, we can and we will issue and ask for the statistics. We want to query only a specific set of data, so we will add where here, meaning that we can provide some predicate that will filter our data. And now is the crucial point. As you can see, you can ask nicely to do the Laizly async. What it does, it will add this query to the session and it will wait. It will not execute the query immediately, and it will wait for the first opportunity when the request is sent over the wire to the server to execute it. So we just saved one request here. Let's follow it with the next sentence and the next statement that we use to obtain the book. As you can see, we use the load async book. This is just a regular load entity or load document by an ID. What you probably also noticed, there is an additional clause just before the load async, and this clause is called include. What it does, it allows us to just pass an expression that specifies what should be included in the load for the given book. We already know that book includes the author ID. So if we ask session to include the author ID document, meaning the document identified by the author ID that is provided by this property, and then we load the book, this will be executed in only a single request. Okay, now you may ask, what happens with the author? I mean, we just loaded it, but how we can retrieve it? So the session provides the identity map and in a kind of unit of work fashion. Once this author is loaded, you can always load async, and first, before going to the server, it will check whether the author was already preloaded. It was because we asked for the book. So what we did is we got the availability for the given book copy. We included the load of the author in the book, and then we loaded the book. Actually, we just issued one single request to load all the data. Now you may ask, okay, it's also possible to do something similar with SQL. Yes, you could join multiple tables, but I find this single statements where you split what you want to do from how you do it, much more nicer to follow. We just query and then we ask do it lazily. We load something, but we ask also please include something that this document references. This allows to structure your code in a really simple and straightforward fashion, and it just jumps over the wire one single time. A similar approach is taken by the method that retrieves the author. As you can see, again we are building the identifier, then we query the books. We just issue the query against the books by author index. Again, we will retrieve the stats, we'll add a predicate, and then we'll lazily query to retrieve all the books written by the given author. Then we will load the author. Again, this, as this is the first actual request that will go over the wire to RavenDB server, this will be combined with the lazy books and it will get them in a single round trip. Then we can return JSON result including author ID, first name, last name, but also all the books, meaning their identifiers and titles. Now you may ask, does it work everywhere? Maybe there is an author that wrote a lot of books, so let's check it. To check it, we'll of course pick up a book like Shining maybe, have you heard about it? And the author is Stephen King. If this app breaks because of the number of the books written by one author, Stephen King might be the case. So let's click on him and we can see that first there is like a lot of books here and all of them were loaded in a nice and fast fashion. You can also notice that I'm generating some identifiers based not on the actual author, but some hash of their name. Clearly this is not Stephen King, but you can see that this page works just fine. Again, we combine the Laizly async, and although the include wasn't included in that particular case, still it lies on the table as an opportunity to reduce the number of requests that you send over the wire to the RavenDB server. So now let's cover an aspect that is very frequently raised, especially if you work in a cloud environment where you need to pay for any egress data that your application sends over the wire to the client. To show how we can use it and how we can leverage RavenDB to send less data or almost none data over the wire, let's take a look at the screen that you can inspect the network connectivity with. So if you hit F12, you can see that there is the network tab, and then we will try to refresh the page. I just want you to know that I just cleared the caches beforehand so that we will see the very first load of the page what is going on here. As you can see, we got a few requests. So the first is that we get 2 counts clearly. Someone was not capable of implementing the UI properly, meaning me. Then we got the 1 options for the count, 1 options for the actual Stephen King page. This is due to the course. And then we loaded the data of Stephen King, and that is a lot. That is over almost 5 kilobytes of data sent over the wire. You may say, this is not that much. But if you add such a request, especially in a cloud environment where you quite frequently need to pay for the egress data, these numbers add up pretty quickly. Let's try to refresh this page again. Let's see what happens when we refresh the same page again. Okay, as you can see, something happened with this request that gets all the data required for the Stephen King page. Again, just to repeat, we are loading the actual author's data, but also all his or her books. So we can see that we just got it from the cache and that the actual response from the server was 304, meaning not modified. Now you may ask how the server knew that it required nothing to send over the wire. If we take a look at the request and the response headers, there is one thing that is required for that to work, and this is the Etag header. As you can see, our request, because we already had a previous version of the resource, meaning the previous version of the data related to Stephen King, when we're sending the request, the browser added the if none match, meaning that it added the previous version that it cached on its side. Server was capable of validating that and responding with not modified and the Etag that is exactly the same that the client sent over the wire in the request. So we just saved 5 kilobytes per a single request and just sent a few headers in the response instead of the whole payload. How is it done with RavenDB? Let's take a look. As you can see, in the very same authors/id method, we are constructing the JSON result just as is. So we are not optimizing retrieving data from RavenDB. We will query the data, we'll get the stats, we'll get the author, we'll get everything, and we'll construct the result. But then we'll enter a method that does something with it. This try cache publicly method is a simple extension method that combines several things. First, every single entity, every single document in RavenDB, it has its change vector. A change vector, you can think of it as a version of the given document. If nothing is changed, and in that case, Stephen King, I hope he didn't write any book from the moment of the deployment, at least I'm not aware of it. So the Stephen King document, it didn't change. Then we have one more thing, which is the statistics. This is the component that is retrieved with the statistics method from any query. If we take a look what they have inside of them, and this is used by the build Etag, you will see that every single query that is returned by RavenDB server, it includes the result Etag. So we already have the Etag for the query. And if nothing changed, and we can validate it, we are sure that we will present the data that are up to date, but we do not send them over the wire if the client has an already pre-cached version of them. Now let's go back. You can see that we are adding the vector for Stephen King, the stats and the Etag that results from them, and then we try to cache publicly. What we do is that we validate if the header sent from the browser is as requested. If it is, we can just send not modified, and we are just good. We are not sending any data. We are just telling the client we are good, move forward. Your cached version of the data, this is correct. If this is not the case, we just return the data, but we ETag them anyway, so that if this very same client tries to take a look at the Stephen King's page, they will have the data served from their cache, and it will require almost no egress data for us to be paid when we send the data from our cloud to the client. Now going back, you may say, oh, this is not that important. What I'm trying to show you is that actually RavenDB provides you with like small building blocks that you can leverage, and in that case decrease the amount of money you need to spend on the egress data. Of course, as long as the client ensures that they cache everything in a right way according to HTTP spec. All right. We were discussing the library application, and we covered a lot of features of RavenDB, but actually we haven't covered the application itself. And one of the most important things that you probably notice is this one beautiful bell with some icon on it. Let's click on it. As you can see, we have some notifications here. Here there is like the welcome message. We can check out this random book, and if we go to this, we can see that, ooh, that's a nice title, Three Little Pigs. What a book it is. So we have 4 of 4 available here, and if we click on the borrow button, it will be borrowed. You can assume that we just took one from a shelf and brought it to the librarian so that we can handle the actual physical copy. But for the sake of the demo, let's click borrow without an actual copy of this beautiful Three Little Pigs book. Let's click it. What we'll see is that the book is borrowed, and now if we go to our profile, we'll see that we have an active book. If we return it, the book is back. So now if we go back to the notifications and we take a look, we will see that again 4 of 4 books are available. So this is like the whole simple flow of borrowing books. You can borrow and return, borrow and return. And by the way, have you noticed that if you close the notification, this little red dot disappeared? What a nice UI it is, right? Anyway, let's try to borrow one more thing, and that could be maybe some Dostoevsky. Why not? There are 2 copies of Demons, so let's borrow one, and we are clicking borrowing. So it's borrowed. As usual, we'll see that our profile, now it includes the active book. So this is the book that has been borrowed by us and not yet returned. Again, the profile, it does everything in lazy, include manner, so that we don't send that much over the wire. And the thing worth to mention is that this data change a lot. I mean, if you think about Stephen King and all the books, they don't change that often, but borrowed books, this data are quite hot. So if you want to cache them, probably there is smaller likelihood of having them cached properly. For the sake of the application, the borrowing is done in a way that it will be only for 30 seconds. So once the book breaches the 30 seconds, something happens. And this is quite important. First, there is a notification. Your book, Demons, is overdue. Okay, so let's close that. And if we go to our profile, we'll see that the book has been marked as the overdue. This is something interesting because the only thing that happened was that some time has passed, 30 seconds. We did nothing else. We haven't clicked anything here. And as you can see, the book, it has been moved from the active books to the overdue. Okay, now we can ask for forgiveness. We can say, we are so sorry that we kept this book for such a long period of time, like 30 seconds. It's an eternity. So we can return it and we are just good. The book is returned. And now if we took a look at it, we would find that again, all the copies are available. But now the question is, how can you design a process and how your database can support you in making a reason out of these 30 seconds? Meaning that if you think of it, usually you need to incorporate some third party. You need to get a library, you need to get even a whole framework to model the passage of time. How can we do that with Raven? Let's take a deeper look. First, we need to familiarize ourselves with the idea of the borrowed book. So how I model this application is the following. Every single time a user borrows a borrowed book is created. It will have its own identifier. It will be referenced to the given user. It will be referenced to the given book copy because we try to simulate the physical world, so we are borrowing an actual copy of the book, not a book in general, but an actual copy. Then for sake of keeping things referenced and easier to look up, we just add the reference to the book ID. And then we have a few dates. So first, this is the borrowed from, which is we are borrowing from that date time offset. Then there is the period of time where this book is not overdue. So this is borrowed to. But once this book is over this time, what we'll do is that, this book is overdue and should be returned as soon as possible. The last thing is that we are capturing the date of returning the book. So if a book is returned, that will be tagged in here, and the corresponding book copy will be marked as available again. Because if we take a look at the book copy, a book copy can be available or borrowed. No other state is possible. So now, as we know how a process of borrowing book is implemented and how it is modeled actually, we can take a look at the implementation. So the borrowing happens when the UI posts at user/books the payload. We will simulate it and we will query the book copies that are assigned to the book ID. So we'll pick up one of the available copies and we'll try to lock it for the user that is requesting it. Again, in a real world, we would come up with an actual copy from a shelf, and probably the librarian would just scan the QR code or whatever the code there is, or enter the number, and that would be the book copy that is assigned to the given user. As you can see, we set the book copy ID as mentioned, book ID, user ID, then we set the borrowed from, and we set the borrowed to, because we know for how long we want to borrow this book. And this is 30 seconds only. The time flies, right? Then we store this borrowed book and we are almost done. The one thing that we should mention is the time. So now we know that the book is borrowed to, and we may use some feature of RavenDB to keep a clock ticking for it. What we will do is that we'll use a helper method that is called schedule timeout. RavenDB allows you to set and get some metadata for every single document. And some of this metadata are implemented in RavenDB itself, and they do something special. For example, there is the refresh capability, which basically schedules an update to the document. I know, now you may think, what a useless capability, why I would like to update the document. What happens is that once this is done, the refresh metadata is removed. So if you had something listening to that particular change, that the refresh is gone, you may use that to implement a timeout. You don't need any third party, you just listen where the refresh disappears and you do something with it. So if you think about it, that's the way you could implement a timeout manager. To schedule refresh properly, as you can see, we are setting it to borrowed to. Of course, it may take 1 millisecond more or 2 milliseconds more to get the document refreshed from the time where it is scheduled to be borrowed to, but it will be roughly this time. Again, this process is done in batches in a really nice way that doesn't kill the server, so we can clearly use that to perform the timeout management. Now, this is the first part, because now we know that our document will be updated and that the refresh metadata will be removed. But we need something to listen to this particular change. Initially, what I wanted to do is I wanted to make it really simple, because in RavenDB what you could do is that you could react to this refresh in some way and update something. But I wanted to push it further and to make it this sample more integrated with other things. So to make it so and to make it aligned with the cloud, as we already discussed the Egress data, I integrated with Azure Storage Queues. So to make it work, we need to react to the timeout. And what we can do with RavenDB, we can use Azure Queue ETL. What it does, it reacts to some documents and it sends a message over the pre-configured Azure Queue ETL. Of course, you can click through it and you can perform the whole configuration using QI, but as I wanted to make it fully manageable with migrations, I'm doing it as a step of setting up the database. So we may think of it as if you had such a change and you use Raven migrations to migrate from one version of your application or service to another one, you could do it in a very same manner. The first thing that is required is the connection to Azure Storage Queues, because then we provide the name of such a connection string and we make this capability possible to work. We are just providing the connection string and we are naming it. That's all. To make it happen, we'll use the maintenance. So document store is, you may think of it as a session factory. This is an object that allows you to create transient session objects that later on can be used on per request basis. It also has the maintenance capability where you can send different messages to. In that case, we are sending the put connection string operation, which, as I mentioned, binds the name with the whole configuration, meaning the connection string to the Azure Storage Queue. So we are done. There is the second part though, because we need to connect to the Azure Storage Queue and then put something in it once the timeout is done. To make it work, we'll use the following ETL transformation. First, we'll assign it and connect it with the borrowed books. So it will work only with documents that are in borrowed books. Second, we'll use the following script. So we'll get the metadata. We know how metadata work, right? Because we already covered that. This is just a dictionary. And we'll check whether the refresh is there. If the refresh is there, that means that this is just a fresh borrow. Nothing happened. What we want to have is that we want to react to the fact where the refresh is gone, meaning it has been already applied, and no one returned this book. In that case, we'll use a special method. So RavenDB provides you the functionality where you can load to queue name. So in that case, we'll load to the timeouts, and what we will load it will be just the identifier of the object. So we will leave up to the consumer of the queue to react to that fact. Again, you could enhance what you are sending over the wire with whatever you want to. The thing is that in our case, we should be just fine with the identifier because we are noticing a possibility that the given borrowed book expired. We need to check it. Now, you may think of it as I would check it in a separate service, and that would be a totally fine scenario. You could use Azure Storage Queues ETL to send some messages over the queue to another service. This is perfectly fine. We want to keep this sample minimal, and we want to also show you that RavenDB is also capable of working with Azure Storage Queues on the other hand. So what we will do is that there is the timeout queue here, and if we go back to the application, Azure Functions application, you will see that method is called process timeout, and it's triggered by the queue timeouts. So again, this is the queue that this particular message is sent to. RavenDB uses cloud events as their format, so anything will be wrapped in cloud event message. What we need to do right now is we will unwrap it. We will get this identifier, and just in case, because we may use the timeouts for other purposes as well, we'll check whether it's the borrowed book. So now we are sure that this is a borrowed book. We could of course check additional properties, whether it's actually overdue or not. We are not doing that for sake of simplicity, but you could clearly do it. And as you can see, we have the session injected here. So we are just loading the book, and we are storing a notification about the fact that the book is overdue. This is what we observed in the application. And then we save changes async as usual. And this is it. As you can see, this is quite a powerful approach. First, we use the ETL integration to send some messages about some of the documents over the wire to Azure Storage Queue. Then in the very same app, we show the capability that even though the given method is triggered by a message in a queue, still we can use the session and integrate with it. So it shows both directions, right? If you had an external service, you could send some message over the queue to that service, and if that particular service communicates with your Azure Functions application, you can use that queue trigger as usual and still enjoy the benefits of using RavenDB and the session management like you see it right here. The library of ravens looked like a really simple small application at the beginning. And that was my idea when I was working on it, actually, to make a sample that is really simple, straightforward and Aspire-based so that you can enjoy it and run it without any problem on your machine. Effectively, what we got is quite a complex but small piece of software. We covered how the Aspire is used by the library of ravens to just make it work on your machine. Then we took a look at the search capabilities, both including the full text search and the semantic search. Then we took a look at all the includes, lazy queries, and everything that you can use to hit the RavenDB server just a limited number of times and make your data show as soon as possible. Then we also took a look at a bit more advanced stuff like HTTP caching and what you can do with RavenDB to limit the egress data that are sent over the wire, especially if you are in a cloud environment. Then we took a look at the borrow process, meaning we went through the application, how it works, but then underneath we took a look at the refresh, timeout management, and all the things that you can do with just Raven and some additional small services like Azure Storage Queues. Then at the end, we showed that also with RavenDB and the whole session management thing, it's quite easy to ingest data and react to data and react to the messages that are sent over the wire or over an Azure Storage Queues. I hope you enjoyed this, and I hope you will get the library of ravens and get it running on your own machine. See ya.